Okay, so we're going to start then adding velocities, and we're going to look mainly at things moving in a current. So whether it's a plane flying in the air, whether it's a boat traveling in the water, we're going to kind of focus on this aspect of relative velocity. So we already saw that we can add vectors together to get relative velocities. And so we're going to kind of just keep going on with that and then think about it also in a two-dimensional way. So this first question is just asking for the airspeed. Sorry, it says a plane has an airspeed of 100 kilometers per hour. If it aims east into a wind blowing at 20 kilometers per hour west, then they want to just determine the speed with respect to, that's what that WRT, with respect to the ground and the distance that it will travel in 5 hours. So we've got a little equation up here. We've got the velocity of the object relative to the ground, so I might just abbreviate that as OG. We've got the velocity of the object relative to the current, so the object relative to the current. And then we've got the velocity of the current relative to the ground. And so again, we see that we're doing this vector addition where we have the tip and the tail, and we get the start and the end point from the outside two letters. So we've got an airspeed, so this is the plane speed relative to the air. So the plane speed relative to the air or the wind, and that's traveling at 100 kilometers per hour. Planes actually have a system in them that allows them to know their true speed in absence of the actual wind. It says it's aiming into a wind that's blowing west. So we've got the velocity of the wind relative to the ground. Wind speed is always measured relative to the ground. And they ask us then to determine the velocity of the speed of the airplane with respect to the ground. So just as a couple of things, this is, it says that it aims east. It says that the wind is blowing west. If I think about directions, I might say that east is positive, west is negative. And so when I add these in a vector way, I'm going to think about putting in the positive and negative. So to get the speed of the plane with respect to the ground, I'm going to take the plane's speed with respect to the wind, which is 100 kilometers per hour. And then I'm going to add in the wind speed with respect to the ground. So if I take the plane speed at a positive 100 kilometers per hour, and if I take the wind speed at negative 20 kilometers per hour, then I get a plane speed with respect to the ground that is 80 kilometers per hour. And because it works out to be a positive value, then this is east. So the next part of this question asks us to get the distance that it'll travel in 5 hours. So when we talk about this distance, we're talking about the distance relative to the ground. And so then to answer this question, all we have to do is realize that this is a constant velocity scenario, and distance in a constant velocity scenario is just d is equal to vt. So all we have to do is take the 80 kilometers per hour, which is east, and multiply that by a time of 5 hours. And so then that distance then is going to be equal to 400. Don't know what I was writing there. 400 kilometers per hour, or kilometers, sorry. And again, that would be east. In terms of significant digits, I would then record that as 4.0 times 10 to the 2 kilometers east.